Okay. So I'm still messing with this t-test and I got some like extra data to talk about. So we had initially spoken about what the t-test is, and basically it's just to compare some values from a sample. All right. Typically it's going to be some averages from the sample, and it references them to a population to see if the averages that you got from the sample actually represent like a difference in the real population. So basically what you're trying to do is you're trying to figure out if what you get from your sample is applicable to the population, pretty much. So we use this example with like engineers and literature kids trying to look at their IQs to see if the averages that we got on paper, like from the sample we'd gotten wrong pen. From the sample, we gotten a average difference of 8, right? And we wanted to know if that's actually going to be statistically different, like on a large scale, as in the population considering the Earth. Okay, so after you use your t-test to do that. Your t-test is actually going to compare the averages and then like extrapolate them via standard deviations and funky math to the population, which is amazing. Thing is, you don't really have any information about the population, but whatever, it's cool like that. And after you get your when you do your t-test, it pops out a p-value, right? So where did I put it? Pops out a p-value. I can't remember why I said it. Shoot, whatever. Oh, here it goes. It pops out a p-value, right? So it pops out that p-value where if your p-value is bigger than zero point 0.5, you can say that the comparison that you have is not actually significant. So in our case, just because the engineers had a higher IQ in our sample, that doesn't mean that the engineers in general have a higher IQ, right? And so we can't say that. We can't say that they have higher IQ in general. If your t-test gives you a p-value that's smaller than zero point 0.5, all right, then you can say that there is a significance there, and you can say actually in general, because the p-test is less than 0.05, we can say with 90 something percent accuracy, depending on your p-test value, your t-test value, excuse me, that that there is a significance there, and so that would be good to go. So I want to add to it. I want to talk about the one-sided t-test versus two-sided t-test. So we got a one-sided, all right, and we got versus two-sided. So when you think about one-sided versus two-sided, it's like looking at when you look at a bell curve. All right, so you got your bell curve where this is going to be your average. Okay, and the t-test basically looks at like the realm. So a general t-test is going to be two-sided. That's to say, if you look at it and you compare the averages, you're going to compare the entire space where you move from the average, okay, to the left, and from the average to the right. I wrote it backward, but you get the point, right? And so when you do that, when you do the two-sided basically looks for any differences, okay? So I'll put two-sided, any differences, and the keyword is any difference, okay? Now, when you do the one-sided t-test, okay, the one-sided t-test adds an extra layer of detail to that. So I got this sloppy-looking bell curve, okay, and let's say our t-test pulls up a significance as such. What it's going to do, what the one-sided t-test does, it only looks at one side, hence the name one-sided, right? And so instead of looking at the left and the right, it's only going to look at the left, okay? And so what it does is it creates a limiting value. So the one-sided t-test, what does that all mean? Like what for real people, for like layman's terms? For one-sided t-test, basically it's better for comparisons. All right, it sets up a more detailed comparison. Okay, and so give me a second to write that more detailed comparison. And so what that means for us is an example would be, let's say you had a test that was trying to see if cholesterol, I'll just put CL for cholesterol, if a drug that, how do I want to explain it? There's a drug, right? And the drug the question is, does the drug lower cholesterol specifically? And so I'll just label it a CHL. So does the drug lower cholesterol, right? So this is our big question. So we want to know if the drug lowers cholesterol and then basically they do a test. And so what happens is they say test A is the people without the drug. So I'll put without, and then B is the people with the drug, right? And so you get an average from the A and you get an average from the B. Okay. You can use a two-sided t-test, and what it would do is give you, is there a difference? Okay. But the difference doesn't say anything about the relationship between A and B. It doesn't say if A is specifically larger or smaller than B, right? And so it doesn't tell if it's larger, if it's smaller, or anything like that. It just says, are they different, right? The one-sided t-test, however, is going to talk about the difference. Okay, so the one-sided t-test is basically going to say, when you do the one-sided t-test, it compares A to B. And so when you do the one-sided, basically what it's asking is A smaller than B? Make some sense? And so that's the whole idea. It depends on which one you use as your variable X versus Y. Okay. And so I actually want to set it up so that it tests to see if B is smaller. And so when I use my one-sided t-test, it will ask the question, is B smaller than A? Because remember, you want the people with the drug to actually have a lower cholesterol, because that is your guiding statement. Does the drug lower cholesterol? And so you would really want the people with B to have a lower average than the people of A. And so you're trying to ensure that this smaller than case is what we're working with. And that's what the one-sided t-test does. It gives you that extra layer of detail to say, is B smaller? Not just different, because different could be bigger or smaller, but specifically, is it smaller? And that's what the one-sided t-test will do. Okay. And if you swap up how you plug in the A and B into the t-test, it'll give you, is B smaller or is A smaller? And that's just a matter of kind of knowing how to plug into the math. But all in all, I just wanted to add that distinction there. Most of the time, in general, in the real world application, people do generally use the two-sided t-test. But the one-sided t-test does have that extra bit of, detail to it that you can kind of fall back on if your two-sided t-test is giving you some funky answers. Okay. So hope that helped.